Okay. Can you see my slide?
Yes, sir.
Boleh. Okay, we will use this slide to see some examples of Bernoulli's equation application. Okay, I hope you still remember the Bernoulli's equation: P1 over rho g plus Z1 plus V1 squared over 2g and equal to P2 over rho g plus Z2 plus V2 squared over 2g. So that's your Bernoulli equation that you will use. Okay, and okay, can we start? Okay, in this question, figure 6.7 shows a siphon that is used to draw water from a swimming pool. The pipe that makes up the siphon has an inside diameter of 40 millimeter. Okay, this pipe 40 millimeter and terminates with a 25 millimeter diameter nozzle. Okay, kat sini ada nozzle with 25 millimeter. Assuming that there are no energy losses in the system. Ada masuk ni. Sebentar. Okay. Okay, please lagi. Okay, please fill up the form, the attendance form. Someone just copy and paste the link again. Okay, okay, for those who just joining, we are doing the example for Bernoulli's equation application. Okay, assuming that there are no energy losses in the system. Okay, so that's what we have learned yesterday. Okay, in any system, to apply a Bernoulli equation, we must assume, okay, that the system has no energy losses. Tak ada energy yang berkurang, tak ada energy keluar atau masuk. Okay, the energy inside the system must be conserved, right? Then you can apply your Bernoulli equation. So that's why in the question they will always mention this. Okay, so calculate the volume flow rate. So your volume flow rate, I hope you still remember, it is the Q, right? Through this siphon, okay, this 40 millimeter pipe, and the pressure at points B until E. So B, C, D, and E. So there are 4 pressure points that they ask you to find. Wait, can I let me make one more. Okay. Okay, so there are 2 questions lah. One to find volume flow rate, and the second one to find the pressure at points B until E. So 1, 2, 3, 4. So 4 pressure points, right? So in this example, in this question, you need to know, okay, some of the information as given in the question. They said at point A, because this surface area is relatively large compared to the surface area at the outlet. Okay, so this outlet nozzle, the area is very small, and this area at surface area for this tank, okay, is large. So we assume that the velocity at A is 0. Alright, so you need to know this. Okay, if they did not, okay, maybe in other examples or other question, they will not provide you with this information. Dia tak beritahu tak beritahu benda ni So you need to know that, okay, the velocity at point A is 0 because this surface area is relatively large, and the pressure at point A as well we consider as 0 because this is open to atmosphere, right? So VA is 0 and PA also 0, right? And PF as well, it give you here PF equal to 0. If they don't mention here, you need to know that the pressure at point F, because it is released to the atmosphere, as we discussed yesterday. So the water is released to the atmosphere, so the pressure at point F is also equal to 0, eh? Ya, dua masuk lagi. Saya allow je. Okay. Tolong paste the link again, the attendance link. So for those who just joining, please fill up the attendance form as usual. Alright, so you need to know the pressure at point F also equal to 0. So don't forget, if you miss this information, you will have a problem lah when you want to solve this question. Alright. So because we know this information, in order to solve the question about volume flow rate, okay, volume flow rate. Okay, first step, what we do before we have learned, write your continuity equation. Okay, A1 V1 is equal to A2 V2. Okay, and V1 equal to A2 V2 over A1. Okay, just write your continuity equation. You might use this equation later on to solve the question. But in this case, because your VA is 0, so this will be 0 lah, tak guna lah. And second step, write your Bernoulli equation. Okay, so your Bernoulli equation. So I take one point at A and second point at F. So P1 over rho G plus Z1 plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G. So this is your Bernoulli equation. Okay, because you have P at A, okay, P1, okay, is 0. So this can be cancelled out. And you also know that the velocity at A also 0. So V1 pun 0. And we also have a P2, a P at point F ni pun 0. So this also 0. And what else? Itu je lah kan. Okay. So you know the Z1. Oh, one more. Z2 is also 0 because this is your reference point kan. Reference your bottom line. Okay. So Z2, Z at F. Ini pun 0. Okay. Z1, Z at A, you can have the information from the picture. 1.8 plus 1.2. Okay, so it will leave to you with Z1 equal to V2 squared over 2G. Okay, and you can find your V2 sama dengan Z 1 times 2G, okay, and set of that. So this will give you V2. Okay, can someone calculate this? Z1 times 2 times G and set what you get for your V2. Berapa? Hello? Berapa nilai V tu? Ada orang ke ni? Ada je. Can someone calculate?
7.67.
Berapa? Sekejap 7.67
67.
So this is your velocity at F, 7.67 meter per second. Alright, kat sini. So you can answer your first question, the volume flow rate. Okay, the Q. So Q equal to A times V. Okay, because you have the velocity at point 2, so you need to use the area at point 2, the area at F. So the area at F, because they gave you the 25 millimeter diameter, so this can be translated into area, which is pi times 0.25 bagi 2 berapa? 12.5 terus 0.0 125 square times 7.67. So what's the answer for volume flow rate? Berapa jawapan dia? Banyak
0.00376.
0.00
3765.
376.
5.
Okay, 5. Okay. Then the unit is
Volume flow rate.
meter
Meter cube per second.
meter cube per second. Okay, well done. So this is your answer, your first answer lah. Okay, I think we have answered. Ada ke jawapan ni? Ada So 3.766 ni lah Okay, so that's your first question. Now they ask you to find the pressure at points B until E. Okay, first you want to solve a pressure at point B. So again we take a point, we compare the point at point A because they have a lot of zero term. Okay, so we take point A and B. Okay, so you need to write your Bernoulli equation because term dekat A ni sangat simple kan. There is a lot of thing that we can cancel out. So P1 over rho G plus Z1 plus V1 squared over 2G equal to pressure at B, P2 over rho G plus Z2 plus V2 squared over rho 2G. Ni one Okay, so we know PA 0, P1 0, V pun 0. Okay, and we can cancel out the Z term because this is the same elevation. Okay, the Z1 can be cancelled out with Z2. Okay, Z at A and Z at B. So this will leave to you only this term lah. Okay, minus V2 squared over 2G equal to P2 over rho G. Okay, so to find pressure at point B, okay, P2 ni, so P2 equal to minus V2 squared times, ni boleh potong G boleh potong, okay, times rho over 2. Okay, so berapa? what's the value for V at point B? Apa nilai dia? Berapa nilai V2? Have we calculated that? Anyone?
7.67 tadi sir.
Mana? Yang ni. This is velocity at F. Kan?
So tak sama.
So you want to find velocity at B. How you can find that? Using what equation?
A1 V1 equal to A2 V2 kot sir.
Yes, that's the correct way. Okay, you use the continuity equation to find your velocity at point B. Okay, continuity equation tells you that A1 V1 equal to A2 V2. Okay, A2 V2. So you have this ni A2 V2 0.00 ni, and you can divide by your area at B. Kalau tengok B, C, D ni semua dalam area yang sama kan? Semua adalah 40 mm inside diameter. Okay, so if you divide Q over so 0.00376 ni divide by pi times 0.02 squared, you will get your velocity at B, C, D and E. Berapa nilai V dia? Berapa nilai V? How much do you get?
2.992.
2.99. 2.99 meter per second. Okay, so this is the value that you will use inside here, okay, to get your pressure at point B. Okay, now you can put back, so 2.99 squared times rho of the water, so you need to know 1000 divided by 2. So what's the value for pressure at point 2? Berapa nilai? Negatif berapa?
447.05.
4470 point
05.
05. I just take this one lah tak muat tulis. Okay, unit don't forget Pascal So this is your answer for pressure at point 2 If you look here, it's 4490. Maybe it's different because maybe the velocity, maybe you take 2.99, and maybe in this case maybe they take 2.99 something ke apa kan. Kat sini awak kira ni mungkin ada panjang lagi, ada semua place dia kan. Okay, but it's just the same answer lah. Alright, so you have answered P at pressure B. Okay, PB. Now at C, okay, you will do the same. You take point at point A and compare. So point A and C, okay, and you will do right similarly like this. Okay, P at A over rho G plus Z at A, okay, plus VA squared over 2G equal to P at C, P2 over rho G plus ZC, okay, plus V2 squared over 2G. Okay, in this case, okay, you can cancel out sama juga, P1 0 and V1 pun 0, and what else you can cancel out. P2 you want to find Okay, Z1 and Z2 you cannot cancel out because you have the value is a different value. Z2 at C is 1.2 plus 1.8 plus 1.2 if you take this is your reference point, and Z1 is equal to 1.2 plus 1.8. Okay, and you have your V2 here is similar like what you have calculated before, 2.99. Okay, so your V, the velocity at point C pun 2.99 juga because it's the same area. So to find your PC, okay, so P2 over rho G, you can label A and C lah if you want to have a clear equation. So this is PA ZA plus VA semua I just take 1 and 2 in my equation. Okay, so P at C, okay, is equal to Z2 minus Z1 plus V2 squared over 2G. Okay, Z2 minus Z1 you can calculate. Okay, Z2, Z at C is 1.2 plus 1.8 plus 1.2, okay, minus 1.8 plus 1.2 for Z ZA. Okay, minus macam ni okay, and plus V2 squared 2.99 squared over 2 times 9.81. Okay, and to find P2 you just multiply this with rho and G. Okay, and then it should give you the pressure at point C lah. Okay, berapa nilai ni dapat, siapa boleh kira? P at C equals to, so 1.2 plus ni tolak ni tambah ni, tu darab dengan rho, darab dengan G. Berapa nilai PC? Apa? Have someone calculate? P2 over rho G equals to, oh salah ni, ni minus minus P2. Okay, I take this to the other side and Z1 to the other side. Have someone calculate it?
Sekejap je.
Okay. So ni jawapan ni awak darab negatif lah, sebab ni negatif negatif P2 over rho G. Saya tersilap. Saya pindah ke sini negatif. So Z2 minus Z1 tambah V2 squared over rho G. So jawapan ni negatif jugalah, negatif something.
Dapat 16242.
Apa?
16242.
162
42.
42.
Betul.
Okay, Pascal. Okay, I think okay. So this is your the correct answer. So lebih kurang lah maybe your kita ambil decimal place for velocity tu lain. So right, so this is your pressure at point C. Okay, you've done this. And do we need to calculate for pressure at D? Do we need to do this similar step?
No.
So what's the answer?
Sama macam A and B.
Sama macam B B, not A
A and B.
A lain A kat luar.
B.
So PD sama dengan PB lah.
Yeah.
Okay. So you don't have to calculate it. And the last one, P at E. Okay, kat sini. You need to calculate again. You can use the point A as well, because point A have a lot of term that is 0. So you do just the same. So A, to calculate point pressure at point E, you take point A as your reference point to compare. So PA, so P1 over rho G plus Z1 plus V1 squared over 2G equal to P at E over rho G plus Z2 plus V2 squared over 2G, and this is 0 and this is 0. Okay, and Z2 also 0, Z at E ni 0. Okay, because this is your reference point. So it will leave to you PE, P2 ni over rho G equals to Z1 minus V2 squared over 2G. Okay, so your P2 will be itu dengan Z1, so Z at A minus V2 squared over 2G times rho G. Okay, so this is your P at E. So berapa nilai P at E? So this equal PD sama dengan berapa? PED pula. P E E. Berapa nilai pressure at point E? So Z1, so Z at 1 at A, 1.8 plus 1.2 equal to 3. 3 minus V2 squared, okay, 2.99 squared over 2G, and this times with rho times with G. So what is the value for rho at pressure at E? Berapa dapat? You get the same answer ni? Siapa dapat ini tak? 24938 or lebih kurang lah, 24 something, 24 berapa? Did you get that?
So saya kira dapat 249 59.95.
Okay, 249
59.95.
0.95. So I think this is a correct answer jugalah, because not too different with this. It might be because of the decimal places that we took in the velocity. Okay, that's why your answer quite only small different lah, but this is the right answer lah. Okay, that's how you solve this first question. Nampak macam panjang, okay, tapi sebenarnya just very straightforward je. Okay, now we look at the second example. Okay, this is a venturimeter lah lebih kurang. Okay, water flows through a pipe at a rate of 170 liter per second. Okay, look at the unit is liter per second. Okay, you need to change that in meter cube per second for your flow rate. The pressure difference between the two pipe section, okay, the pressure difference between these two pipe is measured by a mercury manometer. So there is a manometer attached So determine the deflection H. So they ask you to find this H. Berapa meter kat sini? Okay, this H Okay, so you have your area 1, you have your area 2 as well, because they provide you with the diameter, and you have the row of the water, and you have the volume flow rate. The volume flow rate. Okay, first you need to change the volume flow rate into meter cube per second. So 170 liter per second. How you can change that in meter cube per second? Berapa? What we do? What we do to change this 170 to get in meter cube per second?
Kali
Anyone?
0
Huh?
watt.
Apa?
Kali dengan 0.00 watt.
Okay, so that's right. Or we can divide by 1000 kan? Okay, 1 meter cube is equal to 1000 liter. Okay, so that's why you can cancel out the liter. So this will give you only in meter cube per second is 0.17 meter cube per second. If you fail to change or to convert this in meter cube per second, all of your calculation after this will be affected lah. Okay, you will get the wrong answer. Okay, so that's why I ask you how to change this. I hope by this time you already know how to convert any unit, any conversion unit into the right standard unit. Okay, so the first step is to write your continuity equation. Okay, A1 V1 is equal to A2 V2. Okay, and so you have all your information here to get your V1 and V2, because you have your Q, okay, and you have your area, so you can find your V1 and V2 from this equation kan. Okay, to find V1 you just 0.17 over A1. So A1 is pi times 18 centimeter, so 9 centimeter. So 9 centimeter is 0.09 squared. Okay, and V2 is equal to Q 1.17 over A. So the area for A2 is this one. Okay, it's 10 centimeter. So bagi 2 5 centimeter. So pi times 0.05 squared. Okay, so you will get the value for V1 and also for V2. So berapa nilai V1 kat sini? 0.17 divided by pi times 0.09 squared.
6.68.
6.68 meter per second. And V2
21.64
meter per second. Right. So you have this information, right? You will use this in later on. So the next step is to write your Bernoulli equation. Okay, at point 1, so ni point 1 and point 2. Okay, so point 1, so P1 over rho G plus Z1 plus, so plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G. Z2 Z2. Alright. What term that we can cancel out inside this Bernoulli equation? Apa yang kita boleh cancel out? Anyone?
Z kot.
Z, yes? Betul lah, tak ada code, memang betul. Because it's the same elevation. Okay, your point. So Z1 and Z2 you can cancel out each other. Okay, and bring your P1 and P2 in one side, because that will be your pressure difference. Okay, so P1 minus P2 over rho G, this will equal with V2 squared minus V1 squared over 2G. And this P1 and P2 you can still simplify it to get only P1 and P2 equal to, you can cancel out the G, so V2 squared minus V1 squared over 2 times rho. And so what's the value for P1 minus P2? Because you already get, you have V2 and you have V1, you can calculate the P1 minus P2. Berapa awak dapat kat sini? Berapa nilai P1 minus P2? 21.64 squared minus 6.68 squared divided by 2 times 1000.
211,833.6.
211,833 Pascal, don't forget your unit. So this is value for P1 minus P2. Okay, we still not answering the question because they ask you to find the H. Okay, so in order to get the answer H equal to 1.715, the last step that you need to do is your manometer analysis. Okay, because you have your manometer inside here. Okay, so take your your point, so point 1 kat sini and point 2 kat sini. Okay, so write your manometer equation. Okay, P1 kat sini, and you go down because you don't have any height kat sini kan, from this point to this point. So you need to introduce any term lah, whether it's y or a, whatever. So let's say I take this y height. Okay, so P1 plus, so the row of the water times G times y. Okay, kat sini. And then you go down, so still tambah lagi, so row of the water G times H. Okay, that's H that you want to find, and your point is here. You can transfer your point to the other side horizontally, and you go up, so that's your minus row of the mercury, row of the mercury times G times H minus, so kat sini, and you end your point at point 2, so this y, so row of water times G times dengan y. Saya makin lama makin buruk macam saya ni. Okay, this is row, row. So row water times G times y, this is equal to P2. Okay, so you can cancel out this term, row water times gy, row water times dy, and you can bring P1 minus P2 in one side, say P1 minus P2, so you have the value for that, and you bring the other term to the other side, so row of mercury times G times H minus row of water times G times H, and this can be simplified, G H times row mercury minus row of water. Okay, the value for P1 minus P2, so you have already here 211,833, so this will be 211,833 So you can find your H lah. This one apa yang awak nak cari. So H equal to 211,833 divide by G, okay, G raw mercury berapa? 13,600 minus raw water 1,600. Okay. Can someone calculate whether it's the same with 1.715? Sama tak? Did you get 1.715 or 1.7 something?
Dapat 1.714.
1.714. Okay, that's mean sama lah, betul lah. Okay, so that's how you solve the question. So the step is quite long. Okay, you need to write your continuity equation and Bernoulli equation and your manometer analysis, but it is straightforward je. Do step by step. Okay, and you can solve the question here to find the deflection of H. Okay, remember you need to introduce the height for this, because if you don't introduce anything, you cannot write your manometer equation, kan? And this equation finally will be cancelled out. Okay, but you need to introduce that term, this term, y or a or whatever lah. Okay, boleh faham sekarang? Boleh ada question? Ada masalah? Boleh?
Boleh, sir.
Okay, we continue with our third example. So this again a venturimeter. Okay, but it is in vertical condition. Ini dalam macam ni, horizontal. So this is vertical. Okay, but it's just the same thing. Right. It said the venturimeter shown in figure 6.8, and this figure lah, carries water at 60 degrees. The specific gravity of the gauge fluid in the manometer is 1.25. Fluid dalam ni yang biru gelap ni. Okay, so they give you the SG 1.25. You can find the rho of the fluid. Calculate the velocity of flow at section A. So they ask you to find the VA and the volume flow rate of water, and also the Q. Okay. First thing first, write your continuity equation. Okay. A1, so Q1 over sama dengan Q2. Q1 Q2 equal to A1 V1 equal to A2 V2, and V2. Because you finally you want to find the V at A, kan? V at this point, at point A. If you take A ni as your first point and B your second point, so you need to write your V2 in term of V1, so that you can replace in the later equation. So V2 equal to A1 V1 over A2. Okay, so this equation you will equate in next equation. Alright, so second step, write your Bernoulli equation. Okay, P1, let's write PA lah, senang sikit. So P at ni pun sama, ni V B, and this is V at A. Ni A. Oh, tu dah saya sebab saya buat A1 sebab takut confuse. So this A at B. Faham sebab apa BA ni? So 1 tu lah, point 1, point 2, or point A, point B. Okay. So at point A, so P pressure A over rho G plus Z A plus VA squared over 2G equal to PB over rho G plus ZB plus VB squared over 2G. Right. Can we cancel out anything inside this equation? Anyone? Ada tak term yang kita boleh cancel out? Or zero? Is there any term? Ada?
Tak ada.
Any guess?
Tak ada kot.
Okay, tak ada kan? Sebab there's no term that is zero or no term that we can cancel out. So, but you know that ZA, okay, and ZB, so the difference between ZB and ZA is 0.46. Alright? So this information that you know that ZB minus ZA equal to 0.46 meter. So this, when you write your equation back, okay, like write pressure in one side. So PA minus PB over rho G, okay, equal to, so VB squared minus VA squared over 2G, okay, you bring this to the other side, plus, okay, ZB minus ZA, so you have the value, plus 0.46, okay, right. So this is your equation, and so this ni satu ni dua, second equation. So the third step, okay, the third step is to write your manometer analysis. Manometer analysis, okay, at point 1 and point 2. Okay, let's start at point A. So PA, okay, plus, so you point at here and you go to here and you go down. So this is row of the water, ni water, ni water. So row of water times G times Y, okay, kat sini. And then you still go down, so that means row of water times G times 1.18, row kat sini. Then you pindah point dulu horizontally, and you go up, so that means you minus the row of the gauge fluid kat dalam ni yang 1.25 tu, is right, row of the fluid times G times 1.18. Okay, that means you from here you go up to here, and you need to finish your point at point B. You go up, still you minus row of water G Y minus row of water G times 0.46, and this is equal to pressure at B. Okay. So what you can cancel out this one, row water GY, row water GY, okay, and you bring PA and PB in one side, okay, PA minus PB, so this will equal to, and bring all this term to the right hand side, so row of water times G times 0.46, okay, plus row of the gauge fluid times G times 1.18 minus row of water times G times 1.18, okay, 1.18, and this should give you the value for PA minus PB. And what is the value for this? Raw water 1000 times G times 0.46, okay, plus row of the gauge fluid times G times 1.18 minus row of water times G times 1.18. Berapa nilai P1 minus PB? Anyone? Can someone calculate? Berapa nilai? PA minus PB.
Saya dapat 7406.4 saya.
7406.4.
6.4.
Anyone got the same? Pascal. Okay, I believe your calculation. Okay, so you have your PA minus PB, so this value, and you can replace back. Okay, this is third equation, and then you substitute 3 into 2. Okay, your second equation here, remember kat sini. Okay, PA minus PB, so you have your value for PA minus PB 7406.4, and you want to find velocity at A kan, pastinya you want to find VA, so you need to, that's why I write this VB in terms of VA. You need to substitute VB in terms of VA inside this equation. Okay, so that will give you okay, let's say ni VB ni, okay, VB sama dengan A. You have the everything, you have the area for the area for A and area for B, so you can find the value in terms of VA. Okay, pi, so pi, the area at A, pi times 300 divided by 2, okay, 150, so this will be 0.15 squared over pi, the area at B, okay, 200 millimeter, so it will be 100 millimeter, and that will be 0.1, okay, in meter, 0.1 squared. This can cancel out. So VB equal to 0.15 squared over 0.1 squared VA. Okay, you can get the value in terms of VA. Berapa nilai ni? Ni bahagi ni 0.1 squared over 0.1 squared. Berapa nilai dia? Berapa VB in terms of VA? Ni bahagi ni
2.25.
2.25. Okay, so this 2.25 VA. Okay, so you can replace this VB equal to 2.25 VA inside of this equation. Okay, this will leave macam ni lah. So VB squared will be 2.25 VA squared. Okay, so minus VA squared over 2G, okay, tambah 0.46. Okay, and this everything of every term here you can times with rho G. Okay, and you have your PA minus PB, which is equal to 7406.4. 7406.4. Okay, so you will get VA lah. Eventually you will get VA. Okay, and if you calculate it right, 2.25 squared, okay, 2.25 squared minus 1, that is 1 VA kan, okay, over 2G plus 0.46, okay, times rho G, and you bring to the left side, we lift you with VA, and you will get VA equal to 1.2 meter per second. Can someone verify that? Ada yang kira? So ni yang ni, okay, 7406.4 tadi over rho G equal to or you can bring 0.46 to the other side, minus 0.46. This will be equal to 2.25 squared, betul? 2.25 squared minus 1, so will be 4.06 squared, 4.06 VA squared, okay, divide by 2 times 9.81. Okay, so you can calculate this. Ni bahagi ni tolak 0.46 times 2 times 9.81, and then divide by 4.06, and then you can set the value, and you will get the VA. VA should be equal to 1.2. Dapat ke 1.2?
Dapat.
Good. So 1.2 meter per second. Okay, and to find your volume flow rate, just multiply lah VA with the area at A. Okay, 1.2 times pi times 0.15 squared, and it should give you the value for Q here. Okay, because you have the velocity at A, so you need to use the area at A lah. So AA times VA. Okay, and this should give you 0.084 meter cube per second. Okay, susah ke senang?
Senang tapi complicated.
Tapi complicated. Okay, so that's why you need to write one by one, step by step, your continuity equation, your Bernoulli equation, and your manometer analysis. Nampak complicated sebab dia panjang lah, panjang kan. That's why normally this question give you 12 mark, 12/12. Imagine if you can answer it correctly, you will get 12. Easily you get 12 marks for this question. Sangat senang. Okay, so just read it nicely, properly, so that you not mess up lah with your calculation. Okay, do we need 5 minutes break? Let's have some break lah. 5 minutes and we continue again. Boleh?
Boleh.
Okay. Saya pun penat juga cakap ni. Minum air sekejap. Okay, alright, can we start? Resume our next example. Okay. Ada ke ni? Ada orang ke?
Ada saya.
Ada ya? Alright. So we look at the third, I think fourth one. Okay, example, a piezometer and pitot tube are tapped into a horizontal water pipe as shown in figure below to measure static and stagnation pressure. For indicated water column's height, determine the velocity at the center of the pipe. Okay, they ask you to find the V1 lah, the velocity across this horizontal pipe. Okay. Alright, so first you write your continuity equation, and this is equal to A1 V1 equal to A2 V2, and V1 equal to A2 V2 over A1. So this is one first equation. The secondly, you need to write your Bernoulli equation, which is so P at 1 over rho G plus Z1 plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, can you tell me what is the term is 0 and what's the term that we can cancel out? In your Bernoulli equation, huh?
Z.
Z, okay, 1. So Z1 and Z2 can be cancelled out because it's the same. Okay, what else?
Kat stagnation point tu velocity dia 0.
Okay, and which term is 0 kat sini?
Itu.
V2. So your V2 is 0, so you can cancel out. So that's good, we're done. So that leaves to you only P1 over rho G plus V1 squared over 2G equal to P2 over rho G. So make it an habit to write your your pressure term in one side, so it will look like a pressure difference. Okay, P1 minus P2, okay, over rho G. Okay, this will equal to minus V1 okay, let's write it as P2 minus P1 so that I don't have the minus sign. Okay, so I bring the P1 to over here, P1 to the right hand side. So P2 minus P1 will be equal to V1 squared over 2G. Okay, understand Boleh faham kenapa saya buat macam ni? So P2 minus P1 So this is your second equation. Remember, you want to find V1 They ask you to determine the velocity at the center of the pipe. So it's the V1. Okay, so your V1 should look like P2 minus P1. So G ni boleh potong G sama. Okay, times 2. Okay, your 2 ni kat sini over rho and Z. Okay, kan V1 squared ni kan. So V1 sama dengan P2 minus P1 times 2 over rho and Z. So this is your let's say dia ambil yang simple lah. So this is your second equation. Okay, next what we have to do what?
Manometer analysis.
Manometer. Okay, manometer analysis. Okay, sorry, saya dah tulisan dah makin buruk. Kita makin petang. Okay, so pressure at point 1 and pressure at point 2 is just a rho GH term lah So you know P1 sama dengan rho of water times G times H1 plus H2 kan. H1 plus H2 and P2, okay, at this point, flow of water times G times H1 plus H2 plus H3. Okay, so this P1 sama dengan berapa? Tolong kira. Rho 1000 times 9.81 times H1 3 plus 7 10 cm. You need to change in meter, so that means 0.1 meter. Berapa? 0.1 times 1000 100 times 9.81, so 981 lah. Betul? Betul ke? P1. Ha? Ada yang kira ke?
Betul sih.
Okay. And P2 again 1000 times 9.81 times 3 plus 7 plus 12. 10 tambah 12 22 cm. So 0.22 meter. 0.22 times 1000 times G. Berapa? Berapa nilai P2?
2158.2.
21
58.2.
58
58.
0.2. So this is your P2. Just put back in your equation, in your second equation to get your V1. So you will get your answer for V1. So 2 times 2158.2 minus 981 divide by rho of water 1000. Did you get the answer to 1.53? Dapat tak jawapan 1.53?
Dapat sih.
Dapat. Good. 1.53 meter per second. Okay. Easily 12 mark you get for this question. So or 10 mark, I'm not sure. Mostly 8 to 12 lah. Range dia boleh daripada 8 ke 12 markah. Okay. So I think it's quite easy kan. As you do it many times in your tutorial, you will get that pattern lah. You have to find your continuity equation, your Bernoulli equation, and your manometer analysis. Then you can solve whatever they ask you to find. Can? Okay. The next one, this is a pitot static tube. Okay, and they ask you to find the velocity of the fluid flowing through the pipe. Because sama juga lah dengan ni. Ini pun, ini pitot tube, and this is pitot static tube. So again, write your continuity equation. Okay, A1 V1 dengan A2 V2. Okay, and V1 equal to A2 V2 over A1. Okay, and your second equation is your Bernoulli equation. Okay, this is your point 1 and this is your point 2. Alright, so P1 over rho G plus Z1 plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G. Again, tell me what we can cancel out and 0. Apa yang 0, apa yang cancel out? Z cancel out, because it's the same. And one more thing, apa lagi yang boleh cancel out? Or 0?
V2.
V2 0, because remember your V2 at this point 2, what we call as stagnation point, and this is 0. Okay, remember you need to know this. Okay, because in this question they did not provide you kan, macam contoh soalan pertama tadi kan. Pertama tadi mana? Ni dia bagi kan, VA0 apa kan. So in this question they did not give you the information, so they expect you to know that. Okay, so this V2 is 0. That means you will have, okay, write your pressure difference in one term, P2 minus P1 over rho G equal to V1 squared over 2G, and this can be write again in simpler term, potong G, P2 minus P1 over rho ni darab 2, okay, and this is set. Sama kan macam tadi kan, 2P lebih kurang lah sama pun, bukan lebih kurang sama. Okay, so 2 times P2 minus P1 over rho set, so you will get your V1 equation. Okay, and lastly, the last step, because you still you have your manometer inside this pitot static tube, you need to write your manometer analysis. I just write MA lah, dah tak nak tulis. Okay, I'm sorry. So choose your point 1. So this point 1 P1, okay, and your points here, so you bring to here and you go down, and that means rho GA, okay, rho of the water, okay, G times A, and then kat sini, okay, and you go down, tambah lagi rho of mercury, G, rho of mercury, G times H, okay, so kat sini, and you transfer your point to B, and you go up, and ada H, ada A, so that means rho of water times G times H minus rho of water times G times A, and this is equal to P2. Okay, so this can be cancelled out, rho water GA, and you can write P2 minus P1 equal to, okay, P2 P1 you bring to the other side, P2 minus P1, so this will leave to you only GH times rho mercury minus rho of water. So berapa nilai ni? So G 9.81 times H, berapa nilai H? Ada kerja. Ni H equal to 5 cm. So G 9.81 times 0.05, okay, times rho of mercury 1300, 600 minus 1000. Okay, berapa nilai P2 minus P1? Can someone calculate the value?
6180.7.
Berapa? Again
6180.7.
6180.3 Pascal remember, don't forget your unit. So this P2 minus P1 you put back in your second equation, and this is third equation. Okay, substitute back into, substitute 3 into 2, okay, then you will get your velocity one lah. So V1 equal to set 2 darab dengan 6180.3 bahagi 1000. So the answer sama tak jawapan dia tu 3.52? Do you get that? Sama So the answer is 3.52 meter per second. So easily again 12/12 marks. you get here for this question. Okay? Kan dah nampak kan, makin lama makin senang kan awak buat kan. Betul tak? Kan makin susah. Ha? Can someone say it's easy? Tak ada orang ni, tak ada yang rasa senang.
Dia complicated.
Ha?
Saya rasa benda ni pun complicated.
Complicated. Okay? Remove your mindset. That mindset is not complicated. Is easy, because you just follow this step, your continuity equation and your Bernoulli equation, and then your manometer, and straight away you can answer the question. Okay? So remove your that complicated mindset. Awal-awal mungkin nampak complicated, I understand. Okay, but that's why you need practice. That's why you need to do the tutorial. Okay, we have a lot of tutorial inside the classroom, in the Google Classroom. You can do that, practice, and then you will find it. It is very straightforward. Okay, hopefully lah, boleh insyaAllah. Okay, we have more time. Okay, let's see this example. So this is a tank, right? The water tank. The figure below shows a tank sealed with a pressure of 145 kilopascal. If the depth of the water is 2.5 meter, find the velocity of water discharged from the tank at point 2. So they ask you to find V2 berapa. Alright. Okay, again, this is an orifice lah. If you look at the note, this is an orifice. Application of orifice. So first step, your continuity equation, A1 V1 equal to A2 V2. Okay, and V1 equal to A2 V2 over A1. Okay, that's first. Second, your Bernoulli equation, which is P1 over rho G plus Z1 plus V1 squared over 2G equal to pressure at point 2 over rho G plus elevation 2 plus velocity at 2, V2 squared over 2G. Okay, what we can cancel out in this term? Again, I ask you, apa yang kita boleh cancel out? Anyone? Z? Can we cancel out Z?
Senior.
Why you say that? So this is your Z1 and this is your Z2. Is it the same?
V1 sir.
V1.
P1 dengan P2.
Apa? V1?
P1
P1
dengan P2.
dengan P2. Okay, first tadi yang Z2 apa, kita tak boleh cancel out because Z1 and Z2 is different kan. They have this apa, remember Z ni elevation, ketinggian. Okay, if the ketinggian of both point is the same, then that's why you can cancel out. But in this case, the Z1 is 2.5 meter and Z2, okay, if you took this Z2 as your reference point, so that means your Z2 is 0 lah. Okay, so the difference between Z2 and Z1 is 2.5, so that means your Z1 is 2.5. Okay, 2.5 meter and this 0 meter. Okay, so your Z1 and Z2 cannot be cancelled out, but you can say Z2 is 0 lah. Okay, okay, that's first. Lepas tu tadi saya cakap ni V1 is 0. Okay, that's good, that's right. So V1 is 0 because as we discussed before in the lecture, because of this surface area is relatively large compared to area at this opening yang keluar ni, yang discharge ni, so we can consider the V1 here is 0. Okay, that's good, 0. Tadi awak cakap P1 pun 0 kan? Betul? Siapa cakap ni?
Betul.
Okay, if they don't give you this P, so that means it's 0 lah. Okay, you are right in apa? In right separuh lah, betul lah awak cakap tu. P1 is 0 because it open to atmosphere, but because it said it sealed with a pressure of 145 kilopascal. Okay, boleh faham tak?
Faham.
Okay, that's why your P1 here is not 0. It has some value, and this value has been given to you equal to 145 kilopascal. Okay, so that's so P1 you cannot cancel, it has some value lah. Okay, and tadi awak cakap P2 kan, P2 is 0 kat sini so P2 is 0, betul, you are right, because it is released to the atmosphere. So this term you can cancel out because it is 0. So what is left to us now is only, so they ask you to find the velocity at water discharge, so they ask you to find V2. Okay, you can write V2 squared over 2G equal to P1 over rho G plus Z1. Okay, and we can write it as V2 sama dengan V2 squared to make it easier. Okay, we have P1, so 145 kilopascal, so that means 145 times 1000 over rho of water, this water, so 1000 times 9.81 plus, so Z1 is equal to 2.5 meter. Okay, so this can be cancelled out. So ni yang saya tulis tadi, 2V2 square over 2G. Yang ni, so berapa nilai ni? Can someone calculate this? 145 divide by 9.81 tambah 2.5. Apa nilai kat sini? $17.28. Okay, and so we get V2 is equal to set of 17.28 times 2 times G. Sama tak jawapan dia dengan yang atas tu? Yang ni 18.4. Okay, do you get this?
Sama.
So this is how you answer your question inside orifice. So 18.4 meter per second. Okay, and this normally you get because you don't have a manometer. Okay, you don't have to write your manometer analysis, and normally because it's a shorter work step, only I think this only 8 per 8 lah. Okay, still a plenty of marks. Okay, so the crucial point is to note which one is 0 in your Bernoulli equation and which one has a value. So in this case, remember you cannot cancel out the Z1 because this is not the same. It has a value, so this Z1 is 2.5 and Z2 is 0 because it's your reference point. So that's why Z2 is 0 and Z1 is 2.5. You can only cancel out if this point is in horizontal line kan biasanya. Your point is here, your point 1 and point 2 kumpul kat sini. So this is apa? Sama kedudukan horizontally. That means your elevation is the same. So you can cancel out the z term for both points. Okay, macam contoh yang ni lah So z point kat sini, z1 and z2 is the same elevation from the reference point. Okay, any point lah will be the same height. So that means you can cancel out the z term. Okay, so I hope you understand that concept lah, how to cancel out z. Okay, kau apa dah sekarang? 1.5. Right, so we have done that. Next is this question. Okay, a venturimeter. Okay, so let's do this question. I think that might be the last one before we end. A venturimeter is used to measure the velocity of oil in a pipe section shown in the figure below. For the given data and information, calculate the velocity of the oil at point 1. Okay, they ask you to find the velocity of the oil at point 1 and the volume flow rate in the pipe. Okay, so how we can do this? First, continuity equation. Right, A1 V1 equal to A2 V2. Okay, and you can write this in V1 equal to A2 V2 over A1. Okay, this is your first equation. And you can find the area because they give you the diameter. So this is, we give you the A1 sama berapa, and they give you the D2, the diameter for second section. So you can find your A2 pi r square lah Okay, second step is to write your Bernoulli equation. Okay, P1 over rho G plus Z1 plus V1 squared over 2G equal to P2 over rho G plus Z2 plus V2 squared over 2G. Okay, again, what term that you can cancel out in this case?
Z.
Okay, because it's the same Z1 and Z2 sama kedudukan horizontally. Okay, that means the elevation is the same, so you can cancel out the Z term. Alright, can we cancel out the other P1, P2, V1, V2? You cannot because there is no stagnation point and there is no large surface area or whatever. So all of these have value lah, should be have value. You cannot cancel out this term. Okay, so you can write your Bernoulli equation in term of pressure difference in one side, P1 minus P2 over rho G. Okay, and this is equal to, and bring your velocity to the other side. So V2 squared minus V1 squared over 2G. Okay, so this is your we can call it second equation lah. Alright, and you can, the third step, your manometer analysis. Okay, so you have this manometer inside your venturimeter. So take point 1. Okay, point 1. So P1 kat sini, and you go down. Again, they did not give you any height for this. They just give you this 45 centimeter, and this height doesn't they don't provide you. So you need to introduce any term that can have for this height lah, whether A, B, C or whatever you want to choose. Okay, just choose one. Okay, I choose Y as my height from this point to this point. Okay, so P1 plus the row of the oil, times G times Y. Okay, so your point is here, and then you need to go down still. So plus lagi row of the mercury times G times 0.45 meter. Don't forget to change in, always use in a standard unit. Okay, so your point is here now, and you bring your point to the other side horizontally. You can transfer that point. So you go up, so you minus row of oil times G times 0.45. Okay, so your point is here, and you go up to finish your manometer equation. Minus row of oil times G times Y, and this equal to P2. Saya tak muat lah, sorry. Okay, so this one can be cancelled out, row oil times GY, and you can write your manometer equation in terms of pressure difference. P1 minus P2 is equal to row of oil times G times 0.45. Okay, minus row of mercury times G times 0.45. Okay, and this should give you some value lah. Okay, row of oil they give you here 0.88. That means is the row will be 880. I hope you don't forget how you can change the specific gravity to get the row. You just multiply by 1000. Okay, row of water times 9.81 times 0.45. Okay, minus row of mercury 13600 times 9.81 times 0.45. Okay, what's the answer for this? P1 minus P2. Berapa awak dapat?
Negatif 56.
Negatif 56.
152.
152.
Point 44.
Point 4. Just take one decimal place. 0.4 Pascal. Okay, this equation, just I put 3, need 2. These 2. Alright. Put P1 minus P2 value ni dalam equation, in your second equation. Tak luang dah tulis. Okay, so put this, okay, inside second equation. Put 3 into 2. Okay, so this will give you minus 56152.4 over rho G. Okay, 1000, not 1000, row of oil. Okay, don't forget this row of oil. So this will be 880. So row of oil times G 9.81. Okay, and this equal to V2 squared. V2 squared minus P1 squared over 2 times 9.81. Okay. Alright, so because you have two terms, V2 and V1, and you want to find only V1, velocity of the oil at point 1. So what you need to do is, you need to replace V2 in terms of V1. Okay? Right, because you want to find V2 kan? You want to find V1. velocity at point 1. So you need to replace V2 in terms of V1. So this you should write V2 lah. So V2 equal to A1 or times V1 over A2. So you can equate this inside V2. Okay. And because you have the area 1 and area 2, so you can find mana tulis sini Okay, so V2 equal to pi times A1 A1 ni 15 bahagi 2 7.5. Okay, so this will be 0.075 squared. Okay, bahagi pi darab 45 bahagi 2 22.5 25 0.35 bahagi 2 bagi 100 0.225. Okay, betul? Square V1. Okay, you can cancel out pi. So you will get the V2 in term of V1. Okay, 0.075 squared bahagi 0.225 squared 1.9 0.11. Okay, so this will be V2 equal to 0.11 V1. Okay, just replace back inside here. Okay, so V2 squared equal to 0.11 squared V1. 0.11 squared sama dengan 0.07 so you will get 0.0123. Okay, 0.11 square itulah 0.0121 V2 squared minus not V2 V1 V1 squared minus V1 squared over 2 times 9.81. Okay, so 0.0121 minus 1. Okay, you will get minus 0.98. Divide by 2 times 9.81. Okay, and then you multiply by this 880 times 9.81, and then divide by negative 56152.4, and then set of that value, you will get your V1, and should be equal to 11.4. Okay, V1 should be equal to 11.4 meter per second. Okay, boleh? Tak boleh kan? Boleh kan?
Boleh je.
If you do this, okay, now it's only 150, you will get lah. So you already put everything here, okay. V2, V1 with the V2 in terms of V1, because you want to find V1. They ask you to find V1, that's why you replace V2 in terms of V1. Okay. And lastly, the volume flow rate is just multiply lah by A1 or V1 or V2, A2 lah, whatever you want to choose. Okay, so you will get your volume flow rate. Okay, so just multiplication of A and V. Okay, I think that's all. This will you can do this. You can try to do this and this and this. Okay. And other question in the Google Classroom, I've posted the tutorial, example of tutorial. You can look at that as well. Okay, do it by your own, and it should help you lah to find and to understand more on Bernoulli equation application. Okay, I think that's all for today. It's already 1:50. Thank you for your attendance. Alright, thank you for your involvement. We shall meet again next week, and we will cover the last subchapter lah of chapter 3, which is linear and angular momentum.